Hi, hello everyone. Welcome to this video. So this video is direct continuation of the previous one when we were talking about shadows and shadow mapping. So we left off with our shadow texture, which were just basically these two pedals and this small cube, which was projected from this pedal, this cube, and then one pedal here, right? We have projected it to depth map. So we're going to use that depth map or shadow map as well. It can be called that as well, even better. And we're going to use it to actually create the shadows on our floor. So let's get started with it. So first of all, we're mostly going to work within the shader. So mostly just passing information to our shader and then doing the math in the shader. So material shader. And one of piece of the information that we're going to need is our position of our fragment, but in light space or shadow space. Light space is probably a better name. So what we're going to do is we're just going to say here somewhere where we had the camera. So we're now in material shader. So we're going to need, maybe I can zoom in a bit. So we're going to need this binding tool, and we're going to pass yet another camera, and I'm going to call it light space projection view, and it's of type matrix. So what did we have last time? Well, we had this basically shadow camera, and how did we get these shadows? So just to recap, we had this shadow texture right here somewhere, and how did we get it? Well, basically what we did is sort of this, we kinda had our light, let's say somewhere here is our directional light, right? And we just imagined we multiplied our light with direction of the light, but negative, right? And place it somewhere way behind. And we did this kind of like orthographic projection, right? So I'm terrible drawing, but basically we had our pedal, and then the information about the pedal, right? Let's imagine ray hitting here these fragments, and that information was saved into texture. So we did it for one pedal, second pedal, and then this small ball as well. So basically we had that. So this is just information basically rendered from the point. So we can imagine it somewhere as light being far away and rendering from the point of light. And then we just basically rendered our geometry last time, and we got a shadow map. So we had this, let's just quickly recap so that we remember where we left off. We had this, what's happening? We basically had a shadow pass, right? And the shadow pass, we were rendering just our pedal, second pedal, and ball. And important information was we saved everything to shadow texture. And the other part information that we had was kind of important that we were passing around was this shadow camera, right? And shadow camera was just in direction of light times some scalar like 20, because we had to place it way behind, right? So this part is always going to be like I said, let's imagine it as negative directional light times minus 20 or any other fitting scalar. So it's not super important. So you're going to have to always play with the values to get the best looking scene. But anyway, we got it, and now we have to use it. So why am I saying this? Well, because what we're going to do is the following. So let's see. So we're going to have floor. Let's say this is floor, and then we had also this texture, right? But now we're going to use this light space projection view right here, and we can imagine this as being the camera of our light, right? Exactly, the camera of our light, and it's going to hit some fragment here, right? But also last time we drew those pedals to a texture, and we can imagine when we sample this texture, we can imagine like having some kind of geometry here, right? So it means we're going to have two samples, right? This is already saved in texture, right? Its depth is saved in texture. So we can say, okay, we have this fragment here, we have this fragment here. And if we say, okay, this fragment is closer to our light, right? Then we can say, okay, this is in shadow, right? And then we can multiply it by 0, for example, our light calculation by 0. and then therefore it will be 0 and in shadow. So that's roughly how it works. It's very simple. So its basic idea is just sample this fragment, sample the fragment of our depth buffer, right? So depth information is saved here. We get this fragment, and that's it. We just compare them, and we can see if it's in shadow or not. So the tricky part is how do we sample this texture, and that's what we're going to explain as we go. It's not that hard, but for start we need to get this fragment, right? So we can start with that. So basically, let's say that our camera is here, our original camera, right? So it was also maybe hitting this fragment, right? But we have it in our, so let's call it our normal view space, right? But this normal view space, but this is light view space or light space projection view, whatever, right? The important part is we have our camera for the light and our normal camera. So we have that. So what does that mean? That means that we're going to have yet another fragment here. So we're going to call this, what do I want to call it? Some light space fragment. And here, position, that's actually a good suggestion, why not? It's going to be of vector 4, similar to our position. So here we're just going to say our out light space fragment position is this light space projection view, right, times our fragment position. So the fragment still needs to be multiplied by model, right? It says where it is in space. So we have here position of space, but then we have to multiply it times light space projection view so that we get the correct, well, basically ellipse space, so that we get correct coordinates, and that's it for now. So now the thing is, this is breaking apart. So let's go step by step. We're not going to do anything yet. We have this piece of information. We can fill the data in and then go step by step. So let's start. That means that we have placed this camera here. So we're going to need to do our render pipeline. So we're going to need to have that information as well. Actually, this is maybe way too big. I don't see anything. It's very hard to see anything. But all right. It's probably a bit better, and I can hide this as well, probably, if I only knew how. I'm embarrassing myself today. All right, we have that. So we had our camera, so we're just going to paste another, and I'm going to call it light camera, but actually we call this shadow camera. You know what, it can be called shadow. I use these terms a bit differently. Somewhere I call this shadow, somewhere light, but it's kind of same to me. So let's see here, and when we hit projection view group layout, we have to paste that second binding in. Binding to visibility is vertex shader, and then it's of type buffer. Cool, and then we just need to paste it somewhere to bind group. Here we have this projection view bind group, so we're just going to paste it in, binding to, so resource is of type buffer, and we're pressing shadow camera, not type buffer, we're pressing buffer, and that should be it. This should generally work, but obviously it doesn't, because we have to paste that information to our pipelines. So we can go to our pedal. Let's fix that one first. So here we can just say shadow camera. We already had it here, right, from the last time. Then we can do the second one is ball. It's simpler because we're just spacing. Similar to last time, we had shadow camera in constructor, and then floor. So floor didn't have the shadow camera, so now it needs it. And we can paste it over here. And we still have to do it in main, probably failing here. Okay, it works now. So we paste that information correctly. So let's go further. So next step that we're going to need is also a simple step. If I go to our material shader, so here, let's do shadows here. Let's call it shadows. All right, let's see how it will go. So for shadows, basically, first step that we need to do is to perspective divide. And I'm going to call this shadow coordinates. And it's going to be in, we had this light space fragment position, X, Y, and Z, and we divided it by W. So why is this division by W? So if you remember once when I was explaining camera or projection view, perspective view, matrix, orthographic view, I don't even remember anymore, but let's see what's important here. So I was mentioning that somewhere in the vertex shader stage, right, we had this X, Y, Z vector, and then this W at the end. And it was always question why this W, right? So we mentioned that when we multiplied by matrices, it might be 1, it might be some other value. And then what's important is somewhere in our shader, after shader stage, after vertex stage, this gets all divided by this last value, right? And that's done automatically by any rendering API. So OpenGL, WebGPU, Vulkan, whatever, this will be done, this perspective divide. But here it won't do it, right, for this. So we have to do it ourselves. So that's what we're doing. We're just dividing this by this perspective divide. And usually, just to recap why it's done because this value might be something like 0.1 or whatever, and then this gets scaled. And it's done so that we can have like depth perception, right? So this point and this point, if we have some camera here, are closer to the camera, so they're smaller, they're actually bigger, and then these are further, and in perspective, with perspective projection, they appear as smaller because they're further away. So that's this part. It is very simple. Next part that we're going to need is to actually use these shadow coordinates, and we're going to use them to actually sample a texture that we had last time. So we need to add this texture information. And I'm going to add it right here. So here we're going to have shadow texture. And it's not a texture 2D, rather WebGPU has a specialized type for that, and it's just shadow depth, texture depth 2D. So that's fine. And then we're going to need one more piece of information, which I'm going to get back to. So I just want to pass it. Shadow sampler, and it's of type sampler comparison. I'm going to get to it. I'm going to explain it. It's very simple, bit confusing, but very simple. So what do we need to do? How are we going to sample texture? So let's first... Okay, this is compiled for some reason, but let's first pass that information in. I guess that's important, so we can get back to this, so that we don't have to break our explanations in the future. Let's see. So in our render pipeline, how am I going to pass that in? So we're going to need... I'm just going to do it similar like we had for this other texture, which was diffuse color texture, diffuse texture. But I'll have to refactor it a bit. Okay, let's see how it will look like. So I was creating material bind group. So let's say just here we're going to have binding 4 resource, and then we were passing texture here, but this will also need now second texture, and it's also type texture 2D, but it's going to be shadow texture. Okay, so here resource is actually not like that. I'm getting ahead of myself. So it's going to be texture, not sorry, shadow texture, and then create view. And I did mention that we had a sampler as well, so we're just going to paste sampler from texture. Not right now, if our texture doesn't have sampler yet, we're going to create it, but I have to fix this group as well somewhere. Those are bind groups. Let's see where it is. Those are for lights. Material. So here we're going to paste that information in. So this one is texture, and it's of type 4, and then next one is for the sampler binding file. So here where we had this material bind group layout, we paste that information in. So now we have to figure out this a bit. So how am I going to do it? I'm going to do a simple thing, and then we can decide. No, not going to do it like that. So I'm going to do it like this, private. So here I'm just going to say diffuse texture, and here I'm going to say shadow texture. Okay, and then what I'm going to do here is set this diffuse texture to texture, and then if this diffuse texture does not equal to null end, then we can set it. And this is the shadow texture, and here it can be texture because this is a setter, but then we're going to also have another setter, shadow texture, and very similar to this one. So we're just going to need to paste that shadow texture in, and then if I'm correct, we can just do this everywhere actually in our materials. So at one point I would like to refactor this, but not yet. So that's probably going to be last video or something where I'm just going to clean up stuff a bit. But here in this pipeline, we can actually do it like this. We can make public pipeline. Let's do it everywhere. So then we can just assign simply the texture public, and here as well we can make it public. So annoying part is refactoring all of this a bit. It is what it is. So when we create materials or those objects somewhere here, so I'm just going to say pedal1 dot pipeline dot shadow texture is shadow texture. So we're going to do it for the pipeline too as well. Then we're going to do it for the ball as well. And then we're going to do it for the floor as well. And I think we're good here. So we just need to create that sample because right now that's wrong. So let's go to our texture, and I'm going to explain samples a bit because this needs explanation. This is just passing information so far around. But here, let's just do this const text, this new texture, then we can assign sample. And it's very similar to what we had previously. We can just create a sampler, but we're not going to use all of this. We're going to use compare, and we're going to use less equal. And I'm going to explain it, and then we can return the texture. So now something is still wrong. So let me just see what's wrong quickly. What does it say? Bind groups. So I mess something with bind groups. Group 2, group 4, that's quite alright. So somewhere in render pipeline, probably, let's see, where we were defining our material. 4 is texture, 5 is sample. That's actually alright. So when we create a bind group, this is alright. this is all right, and this is all right. So I'm not quite sure. I forgot to mention, since here I did find it, although it's a bit tricky to figure out, since I have changed our types. So this, if you remember in shader, I mentioned that this texture is actually, it was called something like depth texture 2D. So we have changed sample type, then I'm just going to say depth. And then the sampler is comparison sampler, so we have also to specify type as a comparison. So now it works, and we can get back on track. So let's go to our shader, because this is the only part that we need to change now. It's annoying to have to paste everything in, but we have to do it anyway. So let's discuss further what do we need. So we kind of need to sample that depth texture that we have created. All right, we had this texture, this pedal, and then, so this is our shadow texture. Now we have to sample it. So how are we going to do it? Well, first of all, there is some caveats here. So this space is ideally, it's basically, if we imagine our world, it's usually -1 to 1 space. Its coordinates are that, right? But, and here -1 probably, or above, I don't know anymore. But anyway, the point is our texture is actually a bit different. It goes from 0 to 1 and then 0 to 1 as well. So we need to change that space. And how do we do that? Well, it's very, very simple. So we're just going to need to say here, transform to 0 to 1 range. So we can say here, and I'm going to actually use different name altogether. So I can call it shadow texture coordinates. Shadow texture coordinates. So we just care about X and Y here. We don't need Z. Actually, from here, from the shadow chords, we don't need Z. So we can just say our shadow chords dot xy. So y times 0,5 plus 0,5, right? Because if we imagine this space, right, -1 to y, and if -1 to 1, if we multiply it by 0.5, it becomes 0.5, and 2 minus 0.5, right? And then the same is true for y. And by adding 0.5, this becomes 1, then this becomes 0. So that's what we did here. So as usual, like this y, we just have to reverse it because it's upside down. So let's do that quickly, or we can comment it out, then you can see what's going to happen. So we're just going to comment this later. So now the important part, we have to get some value for our shadow. Now this is the tricky part, right? This is the part where we're saying, okay, let me just quickly move this. So this is a part where we basically have our pedal, which is written into texture, and we have a floor, right? So what's the floor going to be? Well, the floor is going to be basically, how can we represent it? Floor is here, right? We have these shadow chords. So let's just say here, for simplicity, floor Z, or floor Z is fine. So it's going to be shadow chords. Let's see, right? And then we're going to compare it against var. So we're don't have this value yet, so we have to compare it somehow against basically this value, right? So we already projected this one, so we have this depth, right? We have projected it here, so basically its depth is now in depth buffer somewhere between 0 and 1. All right, but now we're going to use one function of basically WebGPU, which is called texture sample compare. Let me just get this right. So it's going to take texture, depth to sample comparison, then the coordinates, we have that, and depth reference value. So this is going to be our depth reference value. So what we're going to do is here, what this function does, is basically, it's going to look into depth texture, right? And this value might be something like 0.2 depending on depth. It might be, it's some value between 0 and 1, right? But so is our z here. It's some value of between 0 and 1. Now we have just to say, okay, is this floor z actually greater or less than some value which is in our depth texture? So, and we get this depth texture, right, from our sample here in the texture coordinates, and this function does it, right? So let's get it now. So the first parameter is very clear. It's very simple. It's just our texture, shadow texture. So what's the second parameter? It's sampler comparison. So it's our shadow sampler. And now I have to explain sampler, but let's do this just quickly. So, and then we have texture coordinates, and then we have depth reference value, which is just our z from the shadow coordinates, right? Floor z. It's actually not good name, floor z, so I'm just going to do this. I just use floor for comparison, but obviously it's going to compare other objects as well, because the shader is for every object. But what is this shadow sampler? Well, this is really annoying part because it's very simple. It's just somehow confusing, but basically it's if statement, right? It has these comparisons: never, less, equal, greater, not equal, greater, equal, etc. But basically what we're saying, okay, so what we're going to say here is, okay, we have this value from the depth texture, right? We got it. We had our texture, we had texture coordinates, we got that value, let's say it's 0.2, and then with the shader sampler, it's essentially saying we used a less equal comparison. It is it less or equal to then some value, which is, we rendered our floor, right? We got this fragment here, for example. Is it less or equal than, let's say that this one is 0.8, and here we had 0.2 for depth. So it's kind of like that. It's just basically a comparison, less, equal, and then you can use also greater, equal, etc. So we got our shadow value, and well, that's it. So we now have our shadow. So if I was just to multiply by shadow, so ambient light, I'm going to leave ambient light, but everywhere else where we had this light calculation, right, light amount here as well, times shadow. So I just added times shadow. Here as well we had a light amount, so times shadow. And then here as well. Times shadow. Let's see what's going to happen right now. So one problem is, you can see these shadowy regions, and we're going to get to that, but one problem is our floor is too close to our pedals. So if I was just to move floor a bit behind, let's say position is something like 4. There you go, we have shadows. You can see shadows right here, right, and right here. And if I was to move up, something crashed. All right, let's try again. If I was to move it, our both pedals are on one key. We're going to fix that next time, but you can see our shadows moving. Only problem is, of course, they're moving in wrong direction, because like I mentioned, it's just this, we have to reverse Y, and we did that. I just left the comment here, we have to reverse Y. And now if I move it, it's still the same. Whoa, wow. Okay, that's weird. Because I call this shadow texture chords Y. Now it's good. Now it's good. So there are still some bugs that we have to fix. So one bug, what's happening? One bug is, I think my tool has crashed, but you can see shadow here. So we can fix that by just adding a bit of bias. We can move this a bit behind, and then this is not shadowed anymore. So we have fixed that. So one issue that you might see at some point is kind of shadows are not going to look correctly if you change some angles. So you kind of have to play with this bias a bit, right? Because what happens is you're sampling a texture, right? But your fragment might not exactly fit the texture correctly, right? It might be like some small differences between the pixels, texels, etc. So you just kind of fix that with a bit of a bias. So you kind of have to play with that value, and you can Google for it. With that said, we're basically done here. So we have our shadows. I wanted to do that. We did it, and that's how you do it. So just to recap quickly. So so we basically had so what we did last time was actually render our scene twice. Once from the position of our shadow camera. So what we had is basically some light camera, right? Which was placed somewhere behind our directional light, and we were rendering pedals. So let's say that our camera, let's imagine ray hitting here, right, these fragments, and we saved that to our depth texture, right, which was something like this. We had our depth texture, so we saved that. And then this time what we covered is basically what we did is we had our scene as normally, but once again we had our shadow camera right here. Then we were rendering a floor, right? So we got that fragment from a floor, and that's exactly here, right? This light space fragment position. So that's a floor fragment. So let's say that we're rendering now floor. We were doing that, and then we got that fragment. We just changed it. We just did a perspective divide on it and moved it to texture space, right? So with that said, right, we could sample texture as well. So we just used X and Y to sample the texture. We had this reference value Z, which is right here, right? And then we were sampling it here, and we got this from the depth buffer, which is some value like 0.2. We compared it against this value, right? Let's say 0.8, or actually it was vice versa. I think 0.8, 0.2. It doesn't even matter, right? You can probably do the math. I'm too tired to do it right now, but we basically got our shadow value, and then we just multiply everything with the shadow value, and that's it. So the functions that you're going to need for that, the new functions are texture sample compare, and we also had this sampler object, which was using where are you, compare, and these are just basically less equal. The provided value places comparison test if it's less than equal to the sampled value. So if this reference value is less or equal to the sampled value, right? If this reference value is less, then it passes the comparison test, and then we can sample. Anyway, that's it. Hopefully you enjoyed this video, and hopefully it wasn't too hard. This thing is kind of hard to explain, but once you do it, once you see it in action, it's not that hard. So if you liked the video, please like, subscribe, maybe leave a comment, and until next time.